Assalamualaikum class. Hope you all are fine. Our today lecture is about green chemistry. So first we need to know what is green chemistry. Green chemistry is a field of science which is related to the production or design of the chemical reactions in such a way that the chemical products which are produced by the chemical reactions are eco-friendly and produce less toxic or no hazardous effect to human health. So here are two definitions of the green chemistry. You can follow any of them. Green chemistry can be designed as a practice of chemical science and manufacturing in a manner that is sustainable, mean environmental friendly, safe and the non-polluting, and that consume minimum amount of the material. I mean less material is used during the chemical reaction or less chemicals are used, and less energy is used while producing little or no waste material. It means no byproducts or no derivatives are produced. The next step is sustainable chemistry. Green chemistry is regarded as sustainable chemistry. Why it is called as sustainable chemistry? Because it is take care the environment and environmental pollution. The sustainable means the development of those products and development of those chemical reactions uh, due to which environment will not get any harm. So green chemistry is sustainable because it protects our environment from the hazardous chemical substances. So there are several important points which describes why green chemistry is sustainable. The first one is economic. The reagents which are used in the green chemistry are economically cost us less, and than in normal chemistry, than in the normal chemistry were the reactants we used. The materials. The material which we use in the green chemistry is uh, non-renewable. Like we avoid in the green chemistry, we avoid to use the renewable resources. I'm sorry. In the green chemistry, we avoid to use the non-renewable energy sources. We use the renewable sources that can be used again and again. So our non-renewable resources can be protected in green chemistry. Like fossil fuels are non-renewable resources and we can get them from the rocks, but they are depleting with the passage of time. So in the green chemistry we must take care of our non-renewable sources. Their use can be minimized. The third one is waste. As we discussed in the definition, in the green chemistry, the scientist must take care the less or minimum amount of the waste is produced. So it is also sustainable with respect to waste. The next one, there is the comparison between the environmental chemistry and the green chemistry. How the environmental chemistry and the green chemistry differs from each other. As green chemistry is a chemical technique in which the scientists manage the waste produced from the chemical processes. Like the scientists take care in the selection of the chemical reactants, uh, uh, which are uh, which are less toxic and which produced less or no toxic products after the completion of reaction. While the environmental chemistry basically is a branch of chemistry in which the scientist study and analyzes the chemical processes which takes place in the nature, and green chemistry has the particular 12 rules, while the environmental chemistry has no rule, but it has the parameter to measure the quality of the air, water, and the soil. In addition to environmental chemistry, also focuses on the effect of chemistry on environmental pollution. So this is the basic difference between environmental chemistry and the next one is chemistry and green chemistry. So what is the basic difference between the chemistry and green chemistry? Chemistry is the study of the matter, the way matter interacts to give rise to a whole range of the processes. And chemistry basically is a science in which the scientist reacts certain um, atoms, molecules, compounds, and make other products from them. And they do not take care the hazardous or harmful effects of those chemical reactions on the environment. While in the green chemistry, the scientists basically specifically choose those chemical reactants which produce less toxic effects or which are environmental friendly. You can see in this definition, like green chemistry is a specific field of chemistry involving the study of atoms, molecules, compounds, and determining whether the usage of such matter is safe for the environment or not. It means while doing any chemical reactions, the atoms, molecules, and compounds which are chosen by the scientist, they choose them with their keen observation whether the usage of those chemical substances would be environmental friendly or not. While in the chemistry, the scientists usually do not take care of the environmental pollution. Green chemistry has a certain principles or rules, and they are the rules of the green chemistry. The first one is prevent waste. Like it means the waste must be prevented to create. The next one is maximize atom economy, less hazardous chemical synthesis, safer chemical and products, safer solvents and reaction conditions, increase energy efficiency, use renewable feedstocks or renewable resources, avoid chemical derivatives, avoid you can say avoid the production of the byproducts or avoid the production of chemical derivatives. Use catalysts which speed up your chemical reactions. Design chemicals and products to degrade after use. It means select those chemical products which can be degraded after their use. Do not use the non-degradable chemical products. Analyze in real time to prevent the pollution means set up the certain equipments to analyze the pollution and to control the pollution. And the last one is minimize potential for accidents, means those chemical designs the chemicals in such a way that an accident can be prevented, like fire or any explosive. So well, here is a uh, short description of those of all the principles of the green chemistry. In the next slide, we'll have economy is equal to formula weight of the atoms utilized in the above chemical reaction divided by formula weight of the all reactants and multiply by 100. So you will have the 50% of all your input. It means converted into product, and 50% is waste by the byproducts or by the derivatives or by the formation of the derivatives. So it's just like if you tell your mom to bake a cake for you and you threw half of the material. So you will not achieve the maximum percent, or you will not achieve the maximum percent yield. You will attain only half of the half of the material from the you used in your input, because you throw away half of the material when you say your mother to bake a cake. And if you throw half of the material, so it means you will get half of half of the input output from the input uh, you put in your reaction. So this here is a need, to uh, chemists to develop the certain chemical reactions in which all of the reactants converted into the products, and there is a no loss by byproducts takes place. Next is use of less hazardous chemical synthesis. What does it mean? Wherever practicable, synthetic methods should be designed to use and generate the substances that possesses little or no toxicity to the human health and the environment. It means that such chemical substances are utilized in the chemical reactions which have no toxic effect to the human health and the environment. And if a chemical reaction have certain toxic effect, so it must be replaced with the other. The next step is design safer chemicals. Design safer chemicals mean those chemical products designed which can preserve the efficacy of function while reducing toxicity. It means the chemical products should be designed in such a way that their toxicity is less and their efficiency is more. As here is an example, medical drugs which introduced into the market. First, the scientists test on those chemical products on animals before apply on humans to test their toxic effect. And if the chemical products proved toxic to animals, so scientists must redesign the chemical products, redesign the drugs, and then apply to the human. The next one is safer solvents and auxiliaries. What is mean? Safer solvents. Use of we should promote, or scientists should promote the use of safer solvents. Use of the auxiliary solvents like separating agents should be avoided wherever possible. Solvents such as the acetone, benzene, and ether are highly inflammable, and other chemicals such as the chlorofluorocarbon are harmful and carcinogenic. Therefore, they must be avoided to use. It means the solvents like acetone, benzene, they are auxiliary solvents and they are highly inflammable and they are toxic to the environment. So their use must be avoided. And if there is a need to use a solvent, then water is the best solvent to use, which is eco-friendly and do not destroy the ozone layer. While the above mentioned solvents, they release a certain gases which can destroy the ozone layer. For example, in the past, for dry cleaning fabrics, a toxic solvent perchloroethylene was used, which now has been replaced by liquid carbon dioxide in the recent years, because perchloroethylene was more toxic and liquid carbon dioxide is less toxic. So it has been replaced with perchloroethylene has been replaced with the carbon dioxide. The next principle is design for energy efficiency. Energy efficiency means use of less energy, and energy requirement of a chemical reaction should be minimized. So here is an important point, that the chemical reaction must be designed in such a way that the energy requirement of a chemical reaction is less. Like for example, carrying out chemical reactions at ambient temperature, it means room temperature or normal temperature and pressure wherever possible, by using catalyst and stopping excessive use of the fossil fuels. Stop using excessive use of the fossil fuels because they are our non-renewable resources. Once they are depleted, they cannot be renewed. Fermentation process is a organic process in which bacteria use the oxygen, and they convert the certain substances like grapes in alcohol, and and milk into yogurt. So fermentation basically is a good alternative uh, of the use of the fossil fuels, which use less energy. And better energy efficiency can be achieved by proper heat transfer and minimum wastage of energy during the process. So the most important point of this uh, topic is the energy efficiency of a chemical reaction must be minimized. It means energy requirement must be minimized. Next, derivatives. Derivatives basically are the products, or you can say the byproducts, which are produced during a chemical reaction, and they are not necessary in a chemical reaction, but they are just the waste products. So minimize the use of the temporary derivatives such as the protecting groups. In the synthesis of an organic compound, it is often necessary to modify or protect the groups on the organic molecules during the course of the synthesis. This often results in the generation of the byproducts not incorporated into the final product. There are certain protecting groups on the organic molecules which are used during their synthesis, but they are not found in the final product. So they are the derivatives. They cannot be found in the final product. So scientists must design a chemical reaction in such a way that they can minimize the use of temporary derivatives, because they just create extra steps in the chemical reactions and nothing else. Avoid derivatives to reduce reaction steps and waste created. The next one is catalysis. Catalysis mean all of you know what are the catalyst. Catalyst basically they speed up the chemical reactions without being themselves used. So chemist basically must promote the use of catalyst catalyst instead of stoichiometric reagents. Why? There are the reasons for it. Waste can be minimized by using catalytic reactions. Catalyst use in small amount. The reason why we should use the catalyst instead of stoichiometric reagents, because catalyst use in small amount and can carry the single reaction many times. They can carry a single reaction many times, and they also speed up the chemical reactions. So when the chemical reaction is speed up, so the less energy will be used. While on the other hand, stoichiometric reagents use in the excess amount and carry the reactions only once. The next step is designs for the degradation. Degradation means the breakdown of a substance by natural means like microorganisms. They can degrade the organic substances. So the chemist must design the reaction in such a way that the reactants and the products can be degraded easily. You can see here design chemicals that can be degraded and discarded easily, and ensure both chemicals and their degradation products are non-toxic and do not persist in the environment. It means the scientist must make it sure that the reactants and the products are non-toxic and they do not retain in the environment for a long time. For example, plastic is a non-degradable. You can see the plastic, if it is found, you found a plastic bottle on the surface of the soil, it can retain on the surface of the soil for hundreds or thousands of the years, and it is non-degradable. It cannot be reduced or degraded by the microorganisms. So we should use the biodegradable packing material, which is made up of plant extracts such as starch and cellulose. For example, disposable plates, glass, and the paper shopping bags. When we go out for a picnic or for travel, we must use these disposable plates, which are made up of plant extracts like cellulose, and we must avoid the use of the plastic bottles and plastic bags and plastic. plates because they create pollution and nothing else. Here is an examples of biodegradable and non-biodegradable resources. We must promote the use of the biodegradable resources like peels of vegetables, paper, wood, and we must avoid the non-biodegradable resources like plastic bags, glass bottles, can, etc. Okay. Our next principle of the green chemistry is real-time pollution prevention. What does it mean? It means such analytical methods developed which control and monitor the pollution prior to the formation of hazardous substance. It means that in a chemical reaction, a certain equipment must be developed which can monitor the pollution before its creation. For example, during the preparation of ethylene alcohol, if the reaction conditions are not properly monitored, if the reaction conditions are not monitored by a equipment or by analytical method, so what happened? If the reaction conditions are not monitored perfectly during the preparation of ethylene alcohol and the temperature gets rise up, then what happens? Hazardous substances may be formed. So the monitoring and the control of a chemical reaction is must. Use of the safer chemicals, the minimum temperature and pressure, and the use of the catalyst for the accident prevention like explosion and fire. So this is real-time pollution prevention. The last principle is minimize the potential for the accidents. Accidents. It means designs the chemicals and their physical forms in such a way that is minimize the potential for the chemical accidents. But the chemical accidents may be um burning of fire or the explosion, and those chemicals or those hazardous chemicals by the fire or the explosion can be released into the environment and may affect our environment and create environmental pollution. So design the chemicals in such a way uh, that they cannot give any harmful effect to our environment.